Okay, so now we're finishing up the review on 5.1 to 5.2. We're on number 19. Find the domain of the composite function f circle g. So the x squared plus 2, remember, is a quadratic. If you need to graph it, you can, to check the domain. X squared plus 2. So it looks like that. So that'd be all real numbers. And the x minus 7 underneath the square root sign, it's going to look like that. I'm not going to adjust my right side, but I know it generally is like that. So it's basically 7 or greater. Remember, if you just plug in like 6 right there, you get a negative under your square root, so that's why it wouldn't be defined there. So it's basically x greater than or equal to 7. Now remember, what we're doing is f circle g, so that means we're doing f of g of x. And so you start writing your f function, so something squared plus 2. And then you plug the g of x into it, so you have the square root of x minus 7. So basically plugging in the function, and now if you're squaring something that's a square root, that goes away. And so this is just x minus 7 plus 2, so x minus 5. Now that'd be the function, and x minus 5, basically, just as a quick sketch, you go to negative 5 for your y-intercept, and it'd be slanted like that. So that's all real numbers. Okay, so for f circle g, what we care about on the domain is the f circle g domain, which is all reals, and the right side, g, which is x greater than or equal to 7. So remember, we care about the right side, and so x greater than or equal to 7. Because if it's not defined for that one, then it can't be defined for the whole thing. And so between these two, combining them, it's just going to be x greater than or equal to 7. Any questions about that? All right. The next one, you have a similar problem. It's f circle g, but this time you have x over x minus 9. As you may remember from our study on rational functions, this one would be vertical asymptote at x equal 9. And so that domain is all reals, x not 9. And this other one would have a vertical asymptote at x equals 0, so it's all reals, x not 0. If you want to graph those, you can, but those are basically the places. I know that they're vertical asymptotes, not wholes, based on the numerator, because the numerator does not match the denominator. If the numerator were factored and if it were exactly the same as part of the denominator, then that would be a whole instead of a vertical asymptote. Okay? All right, so now we're doing f circle g. So you start writing the f function. So that's basically something over something minus 9. And now we plug the g of x into there. So we have negative 4x over x and negative 4 over x right there. So really, you could drop your parentheses, but then you need to get a common denominator of x for this bottom part. Bless you. So our denominator is going to be x, and so this part's going to be negative 4. For this other part, we need a negative 9x. Because think of the x's canceling, so you get negative 9, so it's an equivalent statement. Remember, the reason we do that is so you can mark out these x's that are in corresponding positions. And so you get negative 4 over negative 4 minus 9x. Okay, so that's what the function is, but it's only asking for the domain. So on this type problem, set your denominator equal to 0. So negative 4 minus 9x equals 0. And then just start working it out. And so you end up with x naught negative 4/9. Okay, so for f circle G, we have naught negative 4/9, x naught negative 4/9, and for the G part, we have naught 0. So x naught 0. So those are the two parts we need. If you want to bubble those in, you can. It doesn't really matter. Any questions? Okay. Number 21. The graph is given. Use the horizontal line test to see if it's 1 to 1. It fails. So it's not 1 to 1. It is a function, but it fails the vertical line test. So there's really no work on that. I mean, if you wanted to do a dashed line, you can, but that's completely up to you. Of course, at the minimum or maximum, it would just have one value, but then all the others looks like it have more than one. Okay, number 22. For this one, this one is a very simple one. We have 8x and 1/8 x. So it's the same number, just one of them's multiplying, one's dividing. And it wants to know f circle G and G circle F and if they match. Okay, so we start writing our f function, which is 8 times something, and then plug the 1/8 right there. Then you cross out your 8 and your 1/8 because that cancels, so you get x. So that's for the f circle G. For the G circle F, we start doing our G function, which is 1/8 times something, and then we plug in the 8x. So again, your 1/8 and 8th cancel, so you get x, and they do match. So that's a yes. It's a little more complicated if there's a plus or a minus, but if it's just the same number with a reciprocal, then it should be x. Okay. Number 23, decide whether it's true or false. If f and g are inverse functions, the domain of f is the same as the range of g. Yeah, that's true. Good. So think about the function and the inverse, f and f negative 1. So we'd have the domain and the range and the domain and the range. So these match and these match. So that's what we're talking about. The domain of f is the same as the range of g. And I put the inverse, and that's also G. So just remember, makes an X. Okay. Then this one you do your right side first. So f negative 1, f of negative 1. So remember, on this type, you go to your negative 1, you go to your f. which has y value 1. So I put equal 1. And then you do g of that answer. G of 1. So we go to 1, then we go to the g function, so we get 6. Any questions? Okay, now we do f of 0. So we go to the 0, go to the f, we're already there at 0. And then we do g of that answer, and so that's 7. Then for c, we have g of -1. So we go to -1, go up to g, and you get 5. And then we do f of 5. So you go to 5, go to f, it's this one, and that's 3. So make sure you go to the appropriate x or y value. Okay, g of 4, so 4 is our x value, so that's right here. And we're going to g of 4, so that's going to be this one, which is 4. So g of 4 equal 4. Now we need f of 4. So go to 4, go to f, and we get 2. Any questions? Okay. Number 25. Find your functions. So the first one you do is the outside function. Which is the absolute value of x. And so that's going to be f. And then for your inside function, which is 7x plus 4, that's going to be g. And so your answer is A, because the absolute value of x and 7x plus 4. It's not B because it would have, B would actually look like this, I think. Okay, overall we have 7 something plus 4, and then, yeah, this is what B would look like. Of course, we have A. So that's the difference between A and B. Any questions? Okay. 26. We have these functions, cube root and x cubed, a -8 and a +8. So it's probably going to be an x answer, but we don't know yet. F of g. So we also need to do the domain for each. So the x cubed -8 would be like a cubic function that has a pivot at -8. And this function, let's graph that to be sure, on the cube root, oops, the cube root of x plus 8. I know it's going to be shifted left 8, which is over here. Okay, that's going to look like that, and it's all reals. Okay, so both of them are all reals. Okay, so for f of g, we start writing our f function. And so that's going to be something cubed -8. And then we plug in this for it, the cube root of x plus 8. So here you're cubing something that you're taking the cube root of, and so those cancel. So you get x plus 8 minus 8, so that's x. And since x is also all reals, and we already got all reals for the other part, remember f circle g and the g part, both of those are all reals, and so you put no values should be excluded from the domain. It's the same as saying all reals. Any questions? Okay, the next one, g of f. So start writing your g function. So the cube root of something plus 8. And then we plug in this part, x cubed minus 8. Bless you. So this time you have to drop your parentheses and do your minus 8 plus 8 first, which cancels. And so now you're just left with the cube root of x cubed, which is x. So that's all reals. And again, we're doing g circle f, so we care about the f domain, and both of them are all reals. So this is x, and this is no values excluded. And because they're the same, then it's going to be yes, they're inverses. Any questions?
Wait, what number was that?
That was 26.
What'd you get for the top? F would you? Okay, I got that.
Yeah, x for both of those, no values for both of those, and then yes. All right. Okay. Then our last one, they are restricting the domain to just the right side, basically. And we want to find the inverse. So basically what x squared plus 2 would look like when it's restricted. So you go up to where 2 is and then start your parabola. So it's going to look like that. And we want to do the inverse. So we start with y equal x squared plus 2 and then switch x and y. And from there, start solving for y. So you get x minus 2 equal y squared. So that means y is plus and minus the square root of x minus 2. And based on this restriction of x greater than or equal to 0, we want to use the positive. So this is our inverse, and it's the positive x minus 2. So we get square root of x minus 2. And we know that graph is basically go to the right and then, go over there. Now, let's think about the graphs. Because of the restriction, it can't be A because that's on both sides. And we just have one side. And same thing on it can't be D. So that's going to be the C graph. And again, it reflects across y equal x. All right. Any questions? Okay. You can either turn it in now, or if you want to use it to study your review, you can. Your Math Excel review.